All right, welcome back. We are WEBD6201 in the winter 2021 semester. I'll be okay. And it's week 9, part 1 of our broadcast. So what we're doing today, last week we did TypeScript. We talked about TypeScript and what that is. We converted our JavaScript project with Ajax to TypeScript. We found that there was issues with Ajax Live, and that's not going to stop this week. As we're going to see more issues this week coming up. And this week we're going to be talking about 3-tier web application development, which is really MVC, and there's other models we can use as well. We're going to talk about Mime a little bit, not too much, a little bit about NPM and Node.js and event-driven development. That's what we're talking about. ICE 8 will be due this Saturday as normal, and Lab 3 is due Sunday. And that rounds out our Ajax stuff for this week. And then next week, I'm going to actually release Lab 4 later on today. That's what's going to happen for Lab 4. And then I'm going to talk about it tomorrow during our next recording. So that's what's going to happen this week. And Lab 4 is all going to be around Node.js and Express. That's really what it's going to be around. A little bit more challenging than the other ones. All right, so we're sitting at week 9. Again, we're a little bit ahead. We're supposed to be doing Node.js next week, but we're doing it this week. And that's good because it gives us more time to digest what Node.js is about. All right, so let's talk about 3-tier web application development and what that is a little bit. So again, most web applications, and I mean things, not just a website that's a static website, but a dynamic web application, usually is broken out into a few layers. And it's very similar to what we talked about in the beginning of semester when we talked about the structure, which is HTML, presentation, which is CSS, and then the logic or the behavior, which is JavaScript. And we talked about the importance of having all the structures in place, all the layers, in order for us to have an effective website, because without content, there's no need for structure. And without structure, you can't really do good CSS. And without CSS, really JavaScript, I mean, it's good for behavior, but it doesn't make any sense if there's no CSS and structure. So it kind of builds on that. Similarly, when we build a web application, we have multiple layers, and one of them, of course, is the data layer. The data layer allows us to connect to database or some kind of data store or a data source, and we usually have a model class that connects to that. That's what it's called, the model. We create almost like a template or a schema for our database, and then we connect to it. And then there's the presentation layer, which is the view. And we've been talking about view over the last couple of weeks when we'll be doing a broken out into views with Ajax. We talked about that. And finally, the controller, which is the logic behind the view and that connects the view to the model, right? So that's kind of the, kind of 3-tier application development. On top of that, we also have something like something called our application structure, which follows the same 3 tiers: database, client, server, this kind of stuff, right? In modern web development, it can also be broken out into some kind of database, server logic, and client UI, right? And really what we're talking about here is the model view controller design pattern. And the design pattern that we're talking about is just a programming pattern. It's not something that we need to follow. There's no hard and fast rule about following it, but it's become a paradigm, a way of doing things, as an example, because it makes sense. It's a separation of concerns. So it follows the single responsibility principle, as an example, saying that, we want to break out our web application, especially if it's a monolithic web application, into several different pieces to make it easier for people to work together. And I think this is a good thing. So the way it looks, if you think about it from a diagram perspective, is we've got our user, they make a request to the server, the controller, which is the logic, connects to the model, and when we connect to the model connects to the database comes back with some information, it updates the view, and the view is shown to the user. That's kind of the order of things. And that's a very simplistic kind of way of looking at it, but this is a way of what we're doing. So we're going to be working with an MVC architecture going forward. So we've done kind of the preliminary work. We've broken stuff out, our content, into views already. And the next step, of course, is to take our content and roll it into some kind of back-end server logic, which we're going to do over the next couple weeks. So again, it's been, I would say, evolving over the last 25 years. One of the things that's been happening is a big solution stack that most people are using is the AMP stack. And we've talked about this previously. Apache, MySQL, and PHP is the AMP stack, and there's different kinds. So there's XAMPP, WAMP, LAMP for Linux, MAMP for Mac, and so on. Different kinds of AMP stacks, and they're just solution stacks that kind of have some kind of server, that's the Apache part, some kind of database, which is the MySQL, part, and some kind of backend server logic, which is the PHP, right? There's also the .NET stack, which is a Microsoft solution, which uses IIS as the server, SQL Server as the database, and it uses C# or ASP.NET C# as its backend language, which is kind of interesting. And so this, if you notice, there's different languages and technologies kind of in each of these components to create your architectural stack or solution stack on the back end, plus things on the front end. So as things moved on, and we started adopting more JavaScript everywhere, the idea of JavaScript everywhere, the mean stack kind of grew out of that evolution, right? Where we use MongoDB. MongoDB is a JavaScript-centric or JavaScript-driven database, if you will. Express, which is middleware, JavaScript again. Angular, which is a JavaScript-powered front-end framework with TypeScript support, of course, heavily work with TypeScript, and it's a kind of combination of, like we said before, Google and Microsoft worked on this one. More of a challenge to work on as a single page application framework. And then Node.js, which is our backend backend server, which is what we're going to be working with today, starting today. So if you notice, this JavaScript everywhere, this single language, and it uses JSON objects to pass information from one part of the solution stack to the other. And again, maintaining this idea of an MVC architecture, model view controller. So let's talk about NPM. We've been using NPM from the very beginning, and really what it is the ability for us to connect with the node registry or the NPM registry and download packages so we can include them and empower our web applications. So what they do, of course, is they extend our application capabilities, right, by adding successful packages that have been written by third parties, right, to extend capabilities like we said. So things like, I want to log in, I can download some kind of authentication package. I want to connect to a database, I can download some kind of third-party connection package, as an example. I want to create routing, I can download some kind of middleware package, right? So those are the ways we do things with Node and NPM. So again, think about Node as a platform that we have a bunch of APIs we can connect to. So what is Node then? We've been using Node for a while, but kind of on the sly, I've been, I'll say there's an underlying motive from the very beginning when we got together to get you to use Node all the time. You've been using it the entire semester, right? And but now we're actually going to learn how to really tap into it. So again, back in 2009, Ryan Dahl, he basically presented Node.js, and it kind of grew out of the Google's V8 engine, this kind of evolution of JavaScript and the way the browsers were changing in 2008, 2009 timeframe. And they proposed Node.js as a backend server structure. And the idea of Ajax, which we've been working with over the last couple weeks, that it allows us to create dynamic websites, and we use kind of an asynchronous way of doing things with Ajax. One of the things that we had a problem with was that at the time, web technologies didn't support this two-way data binding. The idea that connecting to the server and getting information from the server, and Flickr was used as an example, which was a kind of an older, and still exists today, an older image sharing kind of platform that was used as an example, right? So that's kind of what happened. Google had this, Chrome V8 engine, and it was something that really inspired the growth of a backend Node.js kind of server. And one of the things that it had this new idea, which was non-blocking sockets, right? Because one of the things that we don't want is synchronous kind of blocking to happen on a server, right? We want to be able to have as many connections or requests on the server as possible, and so we have to use kind of the synchronous nature of JavaScript to make that happen. And one of the challenges was, how do we make it fast enough? How do we make it responsive enough? How do we make it memory performant enough, if you will, to make it work? So really, it's not just a JavaScript execution engine, but also a platform of running very complex JavaScript applications, and that were extensible and scalable, which is kind of the point of this whole thing. Unfortunately, there was a bit of a conflict between the company that owned Node.js at the time, Joyent, and the original founders, which was the people that kind of created it originally, and the founders, so Ryan Dahl and others, kind of broke off, splintered off, and made their own project called io.js. That was the little bit of history. And then eventually what happened was they resolved their conflicts and came back and merged the work that they did on io.js back into Node.js. And now, ever since 2015, things have been rolling. And I mean it like, as in there are regular updates on Node.js every month, pretty much. And even if you were to, to work with Node.js and so on, I think the big thing, the big thing that we're looking at nowadays is how Node.js is evolving, as an example, from where it is today. So there is a new project that's come out, and it's called Dino. It's kind of a weird name, but it's okay. So is Node. So Dino is a project that's grown out of Node.js. So the original founders of Node.js this is I would say, leading edge now. They've moved on and they've made another project. I think it's a project to watch. I'm not sure that it's something that I would recommend for development yet. But I think it's been something that is growing. It's an emerging technology, I would say. And it uses JavaScript and TypeScript from out of the box, things that I love, as well as it's secure from the beginning. It's kind of it's natively secure, as opposed to something that you have to make secure, which is what Node.js is. Node.js is not secure by default. You have to secure it, and that takes additional effort to do. But what they thought about is like, we need something that's secure right away. And I think this is kind of a great way of starting off. I think we're going to see more about Dino, over the next little while. I'm going to see how this goes. But so far, it looks like it's something that's up and coming. So take a look at this. Maybe you want to watch this if you're interested in web application development. All right, so let's continue. So that was the little brief history of Node. And what I want to talk about now is JavaScript event-driven programming, and really that's what inspired Node.js in general for it to work. I mean, we know whenever we do any kind of event handling, for example, let's say we add an event listener like this. Here's an example of an event listener, which is the click event. we want to add it to some kind of element, right? For example, we hook into it by using document.getElementById. We've talked about this semester. And let's say, for example, I have some kind of a button that I want to hook into, and then I add an event listener, which is really a subscriber. If you think about it, events really are, think about them as subscribers and publishers. And we have a watcher. We're watching for some kind of trigger that is going to change something. So for example, a button, I want to click on a button. That is a type of event or a trigger. And we're watching for the event to occur. That's your event listener. And as soon as we're observing a specific item or event, we can subscribe through the event listener. Add event listener subscribes to watching the event to occur, and then as soon as it occurs, it publishes or signals all of the subscribers that the event has happened. So, example, I click on a button, then the function, or whether it's anonymous like this one, right, or if it's a named function, that callback function is the handler, or if you think about this, it's the subscriber. And think about this, you could have more than one of these. I can have 5 different things that are subscribed to the click event. And as soon as I click a button, then all the subscribers get notified that this has happened, right? So similarly, we want to take the same idea of event handling, and we want to apply it to the back end. And this is what JavaScript has done with Node.js, right? So we have some kind of event. Usually it is a request. And what happens is browsers are single threaded, and we want to use asynchronous programming for this, because if we use synchronous programming, that would be impossible. That means like one event or one request would freeze the server. So we didn't want that. And of course, the way this works is by creating this event queue. So we have this event, a bunch of event emitters. As an example, this is an example of the JavaScript events system, if you will, or the event loop cycle. And each emitter kind of sends their signals to an event queue. And then the event loop is kind of on its own thread. And then each event handler these are the subscribers. And the subscribers basically get notified when an event is triggered, when an emitter triggers an event, and the event handler deals with it. So what Node.js does is it listens for any request to come into the server, and as soon as the request comes in, it can respond to the request. And we can create listeners for each of our routes, if you will. We have a route. We listen for a route like index.html. Someone's asking, a user is asking for index.html. They want to see it, right? As an example, that is an event. We're emitting an event, a request, and then Node.js is responding to that event with a handler of some kind, which is a route, okay? So that's the idea behind. So Node.js event-driven programming is exactly what happens. And the way we would do it is similar to, this is kind of an example of a database interaction, which is blocking. Let's go over to the next part. So they use a lot of times the older servers, they use something called a thread pool system. So example, PHP use this thread pool system. And what happens is the problem with this is you have a bunch of idle threads. Once the new threads are created, one new thread is created for every user that kind of accesses the site. And that was the idea behind it. Oh, we can accommodate a lot of users. But what if you have thousands upon thousands of users accessing a site? The threads don't disappear. Once we create a thread, it's created, and it's going to stay in the system until there's some cleanup that goes on. Now, most modern Apache servers deal with this as an example, but the way it looks is something that like this. So here's Nginx. That is a Linux-based server, typically. Nginx is the thing that runs Node.js applications. And you can see that if I get a bunch of thousands of requests per second, as an example, and I have X number of thousands of concurrent connections, as I increase the number of concurrent connections, as you can see, then the ability for me to handle thousands of requests goes down, right? So you can see that I have, I can only handle so many requests at once if I have an Apache server. But you can notice that Nginx kind of maintains stability for much, much longer with a single application thread, which is interesting. We're using the event system here instead of creating new threads. The other problem that Apache has is the more threads it creates, as an example, to accommodate users on the back end, it increases the memory consumption and demands on the server. So you can see it keeps on going up, up, up. As we have more and more concurrent connections, so too do the memory demands go up. But look at Nginx, it just remains flat. So the memory doesn't change because we still have single thread, right? Which is kind of interesting. So this is the way Node.js is kind of in, leading edge, I would say, still technologies. There's still 70% of our, or 70 to 75% of our of websites out there still are using legacy Apache, MySQL, and PHP AMP stacks, I would say. And there's nothing wrong with those. They still continue to upgrade them, and there's still, all kinds of improvements. But slowly, as we move forward, you're going to see more and more, solutions that look like this because of memory consumption and a number of users, especially now during COVID, when we have more people shopping, more people doing things online, thousands of concurrent connections on popular websites. Think about Best Buy with their, PS5 and Xbox Series X craze, people trying to buy those things. It's just as soon as that comes out, they sell out immediately. And how do they handle all those thousands of requests? They have to use a robust system to do that, or else you can crash the system. Think about, holidays, where I have thousands upon thousands of concurrent requests to buy certain things, let's say during shopping holidays, right? And, how do we handle all those things without crashing the system? We can certainly throttle up, increase memory, as an example on the back end, on the cloud. That's a way of doing it. That's just increasing the resources. I want to, throw more resources at something, as an example, for more users. Or we can change our architecture on the back end, which is something that we can do, but it has to happen slowly. And usually it happens during redesign. So if I have a website, as an example, that's legacy and it's working, the rule normally is, hey, if it's not broken, don't fix it, right? Leave it alone because it's working, right? But what if I have to redesign my site? I have something new I want to do, or it's just old. Then we start thinking about back-end technologies as well, all right? It's like, you might as well look at the back end as well because we're redesigning the whole system. So that is kind of the impetus, if you will, or the force behind why Node.js is becoming more and more popular these days. And again, 5 years. Hasn't been a small amount of time. I would say 5 years now since 2015, or let's say 6 years now, since Node.js is kind of formed and combined with io.js. There's been a real, kind of push to use Node.js everywhere. All right, so let's talk about CommonJS and the module pattern. One of the biggest challenges we saw last week was how do we create modules and namespaces for JavaScript front-end frameworks. And we were making our own little API, our Ajax API, right, with our single page application. And we created namespacing for that. And we used TypeScript and we used an IFI. Really, that's what TypeScript converts to. But how do we do that? How does even JavaScript work on the back end? Because there isn't any HTML at all. What you do is connect to some kind of JavaScript file. Usually it's called index.js. But how does it link other files together? Because, imagine if our server and all of our files was just one big massive file. It's really hard to handle. And we want to be able to compartmentalize and break it down across several files. But how do we do that? We need to use some kind of namespacing or module pattern. And back in 2009, CommonJS was born. And what CommonJS does is it uses the require syntax. We use require. And what it does, require means I want to link some kind of JavaScript file onto my main files. That's what I want to do. So I have, let's say, my index.js or server.js. And I want to link on router.js. I want to link on some kind of, database.js or other things that I want to kind of connect to my app.js. or whatever you're going to call it. How do you do that? Well, you need to use the require syntax and something called exports, module.exports. So exports is the method and module is the container. And then what grows out of that is something that looks like this. I have a hello.js file, and I want to do something like module. It should actually say module.exports, and say hello is equal to some kind of function. Okay, now you're going to look at this and go, what? What is this, right? Well, here I have a property, let's say, or an attribute called message, right? Message is a string that is hello. That's what it is. And then we use module.exports, and we attach say hello. Remember, we do in JavaScript when you use the equals operator. When you assign something, you create it, right, in an object. So this is created upon assignment. Say hello never existed, all right? But as soon as we attach it to some kind of function, then say hello is actually a function that points to this anonymous code block right here. And we attach say hello to the module hello.js. So I can actually do something like hello.sayHello, right? So let's say, for example, I use the require keyword. Require, I can point to the file that has my hello.js. But notice that there is no .js here. Whenever we require something, for the most part, we don't have to put the .js extension because require assumes that the thing you're connecting to is a JavaScript file, right? So there's no need for us to put that extra little bit of syntax, the extension. So we don't include the extension here, typically. And what require does is it basically takes the container, the object that we create with module.exports. Module.exports is the object, and say hello is the function. Okay, we take that function, connect it to the object, and then we return it as a reference to hello. So hello now becomes the object, and it has a function called say hello. So again, a little bit of getting used to here, but really the container is something that we're returning. So whenever we require something, we return a container object, and the container object is something that is pointed to by module.exports. Okay, so that's how Node.js knits everything together like this. And going forward, you can make module.exports equal to some function instead of naming the function. Notice the previous example here, right? When we said module.exports.sayHello, right? That names the function, this anonymous function. But we can do it anonymously as well, where I want to say that my function is an unnamed or anonymous function, and I want to attach the function directly to the module. So the module then, the container is the function in this case. Okay, that's all the container is. It's just a function. So then if I say const hello, which is I require hello, just like we did before, then I can just execute the function as if hello is a function. So that's another way of doing it. And you're going to see this kind of pattern when we use Node.js for the latter half of this semester, starting from today. Okay, so that's kind of what it looks like. Common JS modules. All right, and that's how it knits together. All right, so let's think about core modules. So Node.js has core modules, and you can also use third-party modules. One of the core modules that we're going to be exploring that is pre-bundled with Node.js, and Node.js is compiled into a Node binary. So it's made with C++ and compiled into a binary file, an executable, right? And really one of the core modules is the file system module, FS. File system module, we can also require it. Any kind of module that we want to connect or extend our application with, we can use this syntax. Okay, so I want to require some module, whether it's a core bundled module or whether it's a module that is third party. I can combine it, and I can get a reference to it here with this FS, not exactly the most descriptive variable, but most commonly used, to be honest. And then because fs is this, now represents this module, which is the file system module, it has all the syntax and the methods that are associated with the module that are bundled into this reference. So I can do things like fs.readFile, where readFile is part of the file system module. That's what it is. And readFile has its requirements. It has its parameters. And notice that it takes some kind of path, some kind of encoding, and then a callback function. That's what this callback function is. And there's two pieces to the callback function: some kind of error and some kind of data container. All right, and this data container has, it's a buffer of data. That's what it is. And then what we can do is, if we say, if we have an error somehow, so I'm trying to get to this file as an example, and if I have an error reading this file, then I want to output it to the console. Okay, one thing to note is, notice it says return console log. Yes, that's interesting. Well, I want you to also think about what console it's going to. Remember that Node.js doesn't have an HTML page at all, right? There is no HTML page associated with Node.js. So what console are we using then? Where is this going, right? It's going to our command line. That's what it's going to. So it's going to our CLI, our command prompt is where this console is happening. So you're going to see whenever we do a console log in Node.js, it doesn't go to the browser, right? It's not like JavaScript to go to the browser. It goes to the command line, right? And you can see that this is happening twice. I can output to the command line the data that I get from the file, or I can output an error if we can't find the file. A lot of times we look for the type of file that we're missing. All right, so that is an example of a built-in or a pre-bundled module called the file system module. We're going to be exploring also the HTTP module, which allows us to build a server. Let's think about some third-party modules. One of the most, I would say, popular ones that we're going to learn about starting next week is something called Express. And Express is middleware that allows us to create routing and a bunch of other stuff, and more of a robust server with routes and all kinds of lovely stuff that you can combine with Express. But we're not doing it this week. That's just an example of how we can do it. What we're going to do example this week is think about developing a web application with native modules. And the way we can develop a web application is by, yes, we can use third-party modules, or we can use built-in modules that are kind of bundled with Node.js. So let's go there and let's think about how we can do this. So this is an example of making a small little web application. Let's try this out. So if I was going to take this stuff and use it, this would produce or listen for a connection. Okay, so for this in-class exercise, we're going to transition now to the in-class exercise, right, for this ICE. Remember that if you look at our in-class exercise 8, there is a starter. The starter is from last week. All right, so that's in-class exercise 7 as the final. And what I want to do is I want to link to this. Oh, one thing that I forgot to do in our YouTube recordings, of course, is let us bundle our YouTube recording. I know people look for this all the time. Sorry about that, people. I always forget. So I want to, since we're here, might as well do it. And otherwise, I'm sure people are already mad because I'm already halfway into this thing. But at least you have a way of looking at the recording later. Okay, so this is where this is. Okay, and let's just do one more time. Sorry, 1 second, just to link it so that people have a chance to watch and combine this with other ways to watch our content. Okay, so let's look at that content, and I'll go to YouTube recordings here and do the same thing. So we have a chance, give a chance to people who are remote to watch our content in different ways. And that's unfortunate that it does what it does. I wish sometimes it would just pick up the name that's here, but whatever. All right, so that is that. Let's download that starter. So let's download the starter. So if you look at the starter code that we're looking at for today, and that's under in-class exercise. If I go to the starter, It's just this, the in-class exercise 7, and I've taken the liberty of downloading it already, and I've made two examples. One is 9A, that's from the first class, and you guys are 9B. Let's use 9B here by creating, just dragging and dropping everything into our VS Code to start our example here. So last week, what we did was we had this example, and we were running a server as an example, and we've been using so far, we've been using light server, right? So whenever we do light-server, what is light-server? Light-server is actually an Express server equivalent that runs locally for us, and that's what it does. It also uses something called browser sync technology. We can do a lot of this ourselves. So let's, instead of using light server, and notice it gives us some output, right? So the kind of messaging we're getting and so on. Let's stop this and let's make our own. We can use our own. And the way we're going to do this is in the root of our folder for in-class exercise 8. Let's add a new file, and we'll call this index.js, sometimes also called server.js or app.js even. And I want to start tapping into our node information. We're just going to use the this pattern right here that we're going to get right out of the PowerPoint. And I'll talk about this. I'll even grab the last line here, and we'll talk about what this is doing. So let's plump that in. Right, there it is. And I'm going to break this out a little bit for you to talk about what it is. So let's, again, the first step is we use a const. Const is like a let statement, but it's a constant. HTTP, that's the module that's built in. It requires HTTP from the from Node. Node HTTP module is a built-in or core module. And then what I do with HTTP is I create a server, right? Here's my server. Now notice that I also do this, and we'll talk about how to unbind this in a second. And we have two, we have a single, kind of callback function. That's just what this is. And the callback function takes two arguments, a request object and a response object, okay? So what this does, and we'll break this down so we can see it the nice way, the way I like to see it, okay? So it should look kind of something like this, right? Let's space it out a little bit. So we have response write head. Write head actually writes the header to the web page and talks about the Mime type, when in this case is writing text plain. It's saying, I want to write plain text to a page, and I'm going to respond with, at the end, with something called hello world. I'm going to listen on port 3000. Okay. And then I'm going to make a little console log that this works. How do I start the server? I start it by using Node. Okay, let's not do this yet. Let's go up to Node.js. Remember that we've been using Node.js from the beginning, and notice that it looks like we've been working with 15. Something this whole semester. I've updated mine, and I recommend you update your version to the latest version of Node. So if I look at, if I took up my command prompt and I do something like node -- version, you can see that my version is the latest version, 15.11.0. I just updated mine yesterday. I highly recommend you do so for yours as well. And what this will do is it will update you with the latest kind of features if you want to. But also, if you're going to develop live, you're making your own server, the recommendation is to work with the long-term support version, which is 14.16.0. Okay, but either way, you're fine. Also, my NPM, if I do -- version, is 7.07, and a couple of other things. I've also updated Yarn. So if I do Yarn -- version, you can see that Yarn is 1.2.2. And I've also reinstalled things like TypeScript and those kind of things. So anything that once you reinstall Node, a lot of times it's good to update your modules as well. One of the ones I recommend for you to download for today is something called Nodemon. So I want you to issue a npm install Nodemon -G. And what Nodemon is a node monitor. That's what it stands for. If we look at the Nodemon project, right, on GitHub or even online, you can see that Nodemon is a node monitor. That's what it is. And it's been downloaded millions of times. So this is weekly downloads, millions of weekly downloads, okay? And you definitely do this npm install Nodemon. You can also make it so that it's local to the project. This is global to the entire system, right? And the way you do it is Nodemon, and you can target your app as an option. Square brackets usually mean optional, or you can just do Nodemon by itself, right? You can specify the server where it sits and the host as well as the port. So that's how you can do it as well. So host and port, that's how it works. So which is pretty cool. So you can specify where it is. And then what happens is it automatically restarts your server. And we'll talk about why that's important in a second. So I'm going to be using Nodemon. So please install Nodemon by using npm install Nodemon -g. I already have it installed, so I'm not going to do it again. But yours is, I want you to do this. This is a new package I want you to install right now. All right, that's great. So that is what I want to do. And I'm going to bring up our server now. And the way to do that by default is just use node. So I can just say something like on the command prompt, node, and then the name of the server. In my case, it's index.js. If I did this and I do this, it says server running at localhost. And that's the reason why it does this is because it takes this file in, processes it, right? And then creates a server object. And the server object is created by this thing right here. This is the server object. Once the server object is created, it cannot be modified. It's immutable. It's immutable. So as soon as it's been created, as soon as I execute this line, this server stays the same the entire time. It's not something that can change, right? I can't all of a sudden modify what this says here. Here's an example. If I go to localhost 3000 now, let's just go there and try that out, right? So if I type in localhost 3000, right, you can see that I get hello world. There it is, hello world. And if I go back and I want to change this from hello world to hello WEBD6201, right? So I want to make it so that it's a personal message for you guys. Hey, WEBD6201, let us, say hello. How you doing, right? Well, if I save this file, so now it's not saved, but if I save it, the expectation is that if I go back here and if I refresh, that I should get that changed. But remember, my server is running. Because my server is active and real time and running, whatever server I created is immutable. That means doesn't matter what I change here, it will not update the server. And that's a real pain when it comes to development. So typically I don't use a direct command like this, node index.js. That doesn't make any sense for me when it comes to development. Instead, what I do is I use Nodemon. Nodemon does the same thing, but it also allows me to change stuff up. For example, watch this. If I change this back to hello world, right? And it should be written with a comma. And if I press save, it restarts the server for me. Any changes that happen to the server, it restarts the server, and it's not, even though it's immutable, this restart, this little thing that it does to restart the server and to monitor what my changes are is amazing, because then I know that my changes are going to take hold. So Nodemon, highly recommend. There's other ones like this as well. Nodemon is not the only one, obviously. All right, so that is something that how the server works. Let's break this out a little bit more. So again, I'm using the HTTP module. Create server actually returns a server. Notice it says it returns a server. That means I can make a new variable called server. So let server equal to this HTTP server that I've created. Server now represents, it's an object that is created. Think about this as me using the constructor. Create server is the constructor or the factory for me to create a new server. And create server returns a server reference to anything that wants to receive it. In this case, my server variable. Server variable now, it points to the server that has created this. Okay, great. I don't have to do this listening here all in one. I can break this out. And typically what I do is I can do something like server.listen. Server.listen is listening on a specific port. This is port 3000. Typically, I don't want to hard code it this way. This is bad. And so what I can do instead of my port is I can break it down into a const port, okay, which is going to be 3000, and a const host, which is usually localhost, okay, and that is, or 127.0.0.1, however you want to put that down. So those are the things. Let's make this caps, host, and port. And then I can use my port here, right? And I can use my host and port here when I do this. So I can do something like, you know, use kind of template strings, right, as an example. And then where it says this, my localhost, I can pump in a port, so a host, followed by a port, whatever that port is. And that's typically how you might see it. Okay, host and port. And you can see that that is working the exact same way. So that's server running of this. But now this listen actually does a couple of things. Listen actually does, I'm listening on a port. I can also listen on a host name. And I can also have a some kind of callback function. All right, that's what I can have as well. So we'll come back and we'll revisit this in a bit. So this is typically all you can break down. Our little server doesn't do much right now. All it does, no matter what I do, is respond with hello world. And we need to make it more robust than this. By the way, this is a status code that we've seen before. Status code 200 is something that our server responds with. Okay, cool. Excellent. Let's go back to the PowerPoint and see some other basic operations. So here is how it works. It talks about listen and how create server works and so on. And here's another server example, how to serve static files now with Node.js. So here's an example of static files. I'm just going to grab all this time, and we're going to use the same thing by going back to this, and I'm just going to close this off. We can make it, we'll keep this open, and we'll post the server down in here and see what the difference is. So here we have this time not just the HTTP module, but also the file system module. All right, let's take the file system module and also use that. I'm just using this as a pasteboard, if you will. So notice that there's a bit of an error in my code. You just have to put, this is the wrong kind of apostrophe. There we go, file system. So now I'm getting the file system module, which is required as well. So two modules that I'm using that are core modules, all right? I don't need this because I've already done it. I have already created a server with a request response object. Here I'm just using the fat arrow function to do the same thing that this is being done with. But instead of using a write head directly, what I'm going to replace the middle part in here with is this part here, which is my file system read file that we saw earlier. So I'm going to just copy this, and then inside here, we kind of replace this with my file system read file. Okay, cool. And let me explain what these things are. So dir name and request URL, and we don't need to listen on port 8000. We can get rid of all this. We're back to this, right? Let's think about what this thing is. So dir name and request URL. So request has a bunch of different things. Let's take a look at the request object for a second. So let's do a console log of my request object. Okay, so let's look at what that looks like. Remember, I'm only going to get a request object when I do some kind of request anyway. Well, let's see what happens. So save that. And if I go to my server, you see it started. As soon as I go to my localhost 3000 and press refresh, right, it says I get an error number. Error no is 4068, code is IRSDIR, syscall read. That is an error I'm getting right now. Okay, let's see what this does. And let's take a look at that request object. Woo, look how big that is. It's massive. This is the request object I'm seeing in the console right here. All right, and it's actually being accessed a couple of times. So let's take a look at this. It says object mode is false. High watermark is 16384. That's what it says for the request object, right? Buffer is the buffer list, and so on. And you can see that there's a bunch of other properties that are here, right? That are, this is all part of the incoming message, right? That's all part of it. But if you scroll down enough, you get to see a couple of things that this has. And one of them is, as you scroll down and you keep on looking at some of the stuff, you'll see that we'll get to some kind of host, some kind of port. There's the port. We also get things like the user agent string, which is the browser that is inbound. So we know immediately what browser you're using. All that kind of information is coming through the request object, okay? But we know this part, 3000, and we know host. Okay, so why did this fail, right? Because this is a little script that we wrote, and it's not working properly. Why not? Well, let's take a look at the request, this time URL. So request URL, let's see what that is. So save request URL, and if I kind of press refresh here, it still gets the same error. But now, if I go here, the request URL is right here. This is the request URL. HTTP localhost is where we're running, and the request URL is /. And you're going to say, what? /? Yep, that's the request URL. Because the request URL is this part. Okay, so what is dir name? Dir name is actually I'm just going to clear this up. So let's just stop this and we'll clear it so we can not confuse ourselves. Nodemon. Let's take a look at, let's output now what dir name is. Dir name is actually a built-in global variable that JavaScript uses or TypeScript, Node.js uses. So if I do console log, dir name, you can see that that is something we can use, right? And if I press save, and if I refresh the page, you can see now that I'm getting two things. I'm getting /, and I'm getting this, which is the name of my folder. It's the directory name, and that's what this means. It's a what this is something that I'm searching for, right? And inside of my directory. Well, inside my week 9 directory, do I have a /? No, it doesn't know what to do with this /. It's going nowhere. But if I put in /index.html, oh, suddenly we're good, right? Why? Because index.html computes. Now remember, the reason why it's a page not found is because our router that we wrote, right, is being accessed for the first time. So let's take a look at the inspector. And if on our console, what's happening is if we look at sources under scripts, right, then if we look at router.ts, which we wrote in TypeScript last week, right, we can see that the router's been created. And then as soon as we go to the page, it looks at these things, right, these routes, and it looks at location.pathname. And the location.pathname says, let's see what that looks like. So if I was to print it out, let's just do a change here, console log, right? So route, I want to kind of look at that, and I want to save it. And if I search from one page to the other, right? So if I go from here and here, if I don't refresh the page, if I refresh the page, this will be gone, right? That stuff will be gone. It'll give me the same problem. It'll say, I don't know what home is. Take a look at this. It says, let's air out. I don't know. There is no home link to this thing at all, right? There is no home link. But what I can do now is I can create a little router that's in here. So really, depending on the request URL, I'm inside the directory name, right? What I can do is I can parse this before I read anything that I want to read. I can parse this, the information that I'm getting from my request, and pass it into the read file function. The read file function says, take the directory name and add the requested URL. So I can challenge this. I can say, well, what if my request.url is equal to /, right? Equal to double equal, or the requested URL, right, is equal to /. We want to put 2 backslashes because it's an escape character, right? And 2 equals again, right? If it's one of those, then the requested URL, right, is actually something else. And instead of using request URL, we want the path. That's what we're looking for. Or, the path is, we can kind of put that in. So we can say that something looks like this. Let path equal to my request URL. Okay, so this is the request object URL. We don't need to see this anymore. And we can say if my path is my slash or backslash, all right, then we know that we want to make our path, right, equal to what? We're going to combine it with the directory name. So we want to make it slash, as an example, index.html, right? That's what we want. We want to say that if we get one of these slashes, then we want to say path is equal to index.html, and we want to combine it with our directory name, all right? Something that looks like this. Okay, let's see if that works. So save. And if I go back out and refresh, so let's go back to this and refresh, now we're good, right? It took me to WEBD6201 and it gave me that link, right? We can take it one step further. And if I go back to my scripts now, and if I go back to my router.ts, let's output again. Let's go back down into the router.ts file right here. And let's output what the path is that we're getting, the location.path name. Let's put that in there. So we'll do a console.log. Now this console, because it's on a JavaScript file that's a client-side JavaScript file, that's going to go to my browser. The index.js that's here, that is going to go to my console down in here, all right? So I'm going to do a console log. I want to do the route, whatever the route is. I'm going to output that route, okay? And again, the only way I can get that is if I refresh, right? So I'm going to refresh that page, or if I press in enter, and you're going to see that it says a couple things. I don't know what these are, it's telling me. I don't see what these are here, Tom. Why doesn't it see what these are? Because I'm making everything text plain. Everything is text plain. Why? I haven't specified a Mime type, right? A Mime type here. I'm just saying that everything is text plain. That's what I'm saying, okay? Also, I'm responding with the error as an example to my page, right? Instead of responding with this error, we can always respond with either a custom 404 page or just something like error, right? 404, kind of file not found, right? Or page not found. We'll say page not found. Page not found. Okay, that's the error that we can respond with if I don't find a page that I'm looking for. So that's something that is there. Otherwise, I respond with a 200, and then I end with the data. The data is the buffer that I want to send to the page. That's what's happening here. When I res end data, I send that to the page. But the biggest problem that I have here is I'm not dealing with any Mime type. And that's my issue when it comes to looking at the page here. So when I respond, notice I didn't even get my router. And when I hover over this and I try and log in, I get this. I don't know what you're talking about, Tom. Data.users is not iterable, right? And why is that? If I look at my app.ts, right, and which is right here, it says that, hey, I want to get users.json, right? But we don't know what users is, right? We don't know what users is from our data. We went and got data, but because we don't know what it is, right? We have no idea. We can't access this thing because guess why? JSON is not recognized. We have no idea what that Mime type is, and we can't log in. So that is a problem. And to deal with this problem, we can continue to extend our server, right? So far what we've done is we've just made it so we can read any file. It's a static read is what we're doing here in a very small little way. That's all we're doing. And we're just switching. By the way, I can continue to do switching. If I have my path as /content/this/that, again, I can do lots of stuff. And when I go to my index.html, right, I can go index.html slash, and whatever the thing is what I'm going to get. For example, let's suppose that I say slash home. Index.html, right, is the path. So that's the path that I'm reading. And what is the path that I'm getting? I'm still not getting a path from my router. Well, how come? Router is being kicked off. If you notice, if I go back to my scripts, or if I go back to my index, here's my index, my router.js is right here. How come it's not working? Well, first of all, we haven't, router.js hasn't been updated. Remember, router.js is using TypeScript. And even though I modified my router here, my JS file didn't modify here. So I have to run TypeScript. So Control-Shift-B, remember, we did a watch task to run TypeScript, and it confirms and compiles TypeScript now. And if I go back to my console, and if I go to back to the home page like this, then I get slash, right? Slash. And what if I put in another thing? If I said slash home, does that compute? We get a 404 page not found now. Why? Because there is no home here, right? Okay, but what if I did something like index.html slash home? Again, I'm going to get that weirdness because index.html is the page that we're going with. Home is the subpath. That's the actual link, all right, that we're looking at. So that is no good either. So how do we use this if I'm running a little server that looks like this? Well, we don't have to use that information. We can parse everything after the request. So for example, if I get this or this, then I can do this. However, I can also switch any of the requests. So instead of doing this, I can create a switch case. So I can switch the request.url. And what I can do with a switch, I can say case slash or case slash, right? One of those cases. We can do a fall through. Fall through allows us to do this. Path is equal to this, right? That's something we can do. We don't have to do it this way. And we can switch on path instead of requested URL, right? So that's one case. The other case might be something where I use have some of those things inside of my router. So if I look at my router.ts, as an example, I have all of these cases, right? And I have home, about, services, contact, and so on. Let's grab all this just because I don't want to reduplicate this. I'm going to grab all this stuff, right? And I could do a switch case here. I could go back here and put those in. So paste. So we have slash and so on. I can continue with cases. So I can say case and then the next one. Just going to use this as a way of getting my cases in here, and then we'll reformat everything. And then home also would go to index.html, right? So that is also a fall through. So this, or this, right? We don't care which one of those it is. It'll all point to index.html, right? All those three kind of cases. That is the same, right? All right, what about? So let's do another case. So case, right? And we'll say case about. So this, that is a new case. We'll fix it. We'll format this again. Just a second. And we'll do, because it's my funny formatting that's working right now, case services. Just bear with me, guys. And case contacts. Case contact list. And case, I've got other cases here. Projects. and register. So we have a bunch of, these are our routes, right, that we're talking about. Here's our register and also login. Oops. Come on. And finally edit. We don't have a case for doing anything with register, but these are the ones, right? So these are all the different ones. I can get rid of all this. And there's also the default case, then where we have a 404, right? Some other kind of error. That's actually something else that happens. If we get something else, then if it's anything else other than the ones we had, it's going to take us back to the home page too. We can make it so it catches everything, a catch-all, right? And let's format this. Quick way of formatting would be to select all this and right-click and do a format selection, all right? Because that's nicer. That's how it should look. So what about if I do, if I go to the about page? So I take slash, so I say request slash about, right? And what do? Well, really, I want to, the path is the same. It's always path is equal to index.html, yeah? All these are index.html, right? So that is something that's going to happen. Our path starts like this, but then inside of our path, what we want to do is we can produce some other thing. We can produce some other thing. So if our path goes to some other thing slash whatever, then after we read our file and we, instead of responding with the data, right, as an example, we've loaded our file, we've loaded the data for our file that we're going to implement, we're going to output that data, right? Well, what we also want to do is I want to load my index.html, right? And then I can replace it with whatever we have here. For now, we can do all this and it'll do nothing, right? We can always say that the path, regardless of what happens, regardless of what one of these things happens, any default path, we can say that it's just path is equal to index.html, right? So we don't care which one it is. None of these doesn't matter. We can search for specific ones as an example. We don't care, right? But regardless of what path it is, we're going to make it so that it's index.html, no matter what. Okay? So that is the thing. Or we can make it so that the path is some kind of 404.html. We have a 404 page that comes up. If it's here, some other one other than these, then it's a 404.html. We have a 404.html here that I've been using, but it's actually a stub for putting it up on, you know, kind of on GitHub. It was kind of a GitHub fix that I was kind of implementing. So that's something we can do. We can make it so that this goes to a 404.html, whatever that is, right? And we can move path.html no matter what we do. All of these are the same. But we can also have an additional piece of information for our subpath, which is slash services, as an example, right? So for now, let's just do all this, which is really silly, because that's what this means. It kind of goes to my main page, and this is terrible. This is a horrible way of doing it, right? Really bad. But what effect does this have when I go to this? So if I go back and if I refresh, then it's going to go this. It's going to go click, 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 click. Look at that, what it's doing. It's crazy, right? It's trying to figure out what the path is. Let's break that before it goes crazy. Whew, right? Our page broke, right? Let's look at that for a second. I'm going to come back to this page in a second. Excuse me. So localhost 3000, I can't reach it right now. That's okay. Let's restart the server. And when I do that, and if I go to enter, it says, I have some unexpected error. It says my router.js 1, my token is less than, and it doesn't understand what that is because it's going to a 404 and it's trying to figure what this thing is. All right. And my 404 is not a regular 404, right? My index.html is not a regular, my 404 page is not a real 404 page. It doesn't know what I'm going to, right? as an example. And that's bad. Okay, that's really, really bad. So we can change out the index.html, my 404 with my index.html, and then just put in some basic code in here. So we'll grab all this, and we'll go to my 404 page and replace it all with this. And in my content, right, we will go to my 404 page, and it'll just say in my main content, right in here, right, 404 page not found. So H1 404 or error 404 page not found. I'm just replacing it so we can have some kind of stub in here. 404 page not found. Nice, nice, nice. And if I refresh, then it's not going to go anywhere that is bad right now. So that's the first thing that we want to do. So why am I getting a blank page then if I go here now? So if I go /index.html, I get an error 404 page not found. Why? I mean, I did some kind of link, right? And if you look at my index.js, why is this not working anymore? So here's my path, and I'm going down to this. I'm going through switching on path, right? And then depending on what I'm getting, or if I put in something else, right? Anything that I get to, I go this 404. So if it's not, you know, one of these, home, about, services, or whatever, and if I put in the actual link, index.html, I'm going to go to a 404. So what if I put in something like home? If I did like home and press enter. Well, home, right? It goes to here and it goes to my index.html. And we can print out the path. So let's go console log, just to show you the path, console log path, just so we can troubleshoot. And that's an important thing to do, to find out what's going on here, right? And let's bring this up so we can see it. So if I refresh the path, then I get 404, I get an index.html, right? And then I get a bunch of 404s. So why is it? Why is this happening, and why? And I mean like capital W, why? Why am I getting a bunch of requests over and over again, right, to happen? Why is this happening, right? Well, let's do some changes. Let's take away the default case altogether, and let's do that again. So we'll restart, and we'll go to refresh, and now we get our page. Huh? What? How is this working now, right? But before it wasn't working, and now we're getting some really weird error. Look at that. I'm kind of hovering over, and my login page. Remember that we had our problem with our toggle login, right? And if I look at the page, if I inspect the page and I go to console, oh man, we're getting this really weird throttling bug. It says my browser's hanging on app.js 61. I'm going to a history.push state. And why is this hanging on my push state now, where I'm changing my from contact us to services? I can't even move from one thing to the other anymore. I'm locked in this because I got some kind of weird hanging error, right? When I try and go over login.html. Let's refresh that and see what happens. So again, go here, and I'm okay. I was okay to move back and forth, but suddenly I'm locked up. Can't do anything. And it says that, no, I don't know what you're trying to do, but it's really, we're hanging and not allowing you to go further than this because I don't understand what these things are. Okay, let's fix these references. And you can see that it's constantly going to my views, content, contact.html. It's constantly loading this over and over again. Look at that. Constantly. It's kind of clicking that over and over again to load my contact.html. And we never had that before, right? Well, it's the nature of what we're trying to do, my friends. Because remember, it's asynchronous, and this server is responding to requests, a request object that's happening over and over and over again. Okay, that's what's happening here. All right, so that is this, and let's go to the next part. We have a more kind of detailed example, and here I'm actually getting the URL and a bunch of other stuff. So I'm going to grab URL. This is another built-in module. Okay, so here's my URL. Just so that we quiet stuff, by the way, I'm just going to stop our server so it doesn't go crazy, right? So that's our URL. Host and port we have. We're going to do a lookup. So we're going to do a lookup, and the lookup is actually going to be Mime types, okay? Mime types. Mime types is a new third-party module we don't have, okay? So if I go up here and I want to do a lookup, well, it's going to say, I have no idea what Mime types is. There is no Mime types in Node modules. Let's load that up. And to do that, to load a new module, like we've done before, we can do a yarn add, right? And then it's mime dash types, right? Mime types. We want to add, you can use yarn, or you can also use npm. If you use npm, it would be npm install mime dash types, and then you'd have to use -- dev. All right, you'd have to use that. Okay. Oh, -- save. Sorry, -- save. And that would be the same thing as doing a yarn add. If I do a yarn add mime dash types, I'm using a third-party module. That's what it is, to add functionality. And what it's going to do is going to go out to the npm registry, grab mime type, right? Mime types. Okay, because that's what I did. Mime type is what I put in, and it found mime type. It's the wrong one. I can remove it. Hold on a second. Not mime type, Tom. Mime types. Yarn remove, right? Mime type, mime dash type. It's gone. Let's do that again. Yarn add mime dash types. There we go. That's better. Mime types is different than mime type. All right, so Mime types is a third-party module we're going to tap into now. First time we're using something outside of just the regular Node stuff. And let's go back to our little index.js. So we have Mime types. It says, okay, lookup is equal to Mime types lookup. Lookup is a built-in function of Mime types module, right? But instead of doing it this way, let's break it down into, we'll call this Mime is equal to require Mime types. And we'll say lookup, we'll make a little alias. We'll say lookup is equal to mime.lookup, okay? So these are the modules, and we can say that these are required modules. So these are modules that we're loading in, npm modules or node modules, okay? And we're loading in a few of them that are built in, and one of them that is third party. Okay, these are built-ins. Okay, these ones, and this is third party. Let's make this on another line so we can kind of see what that looks like. So one third-party module, 3 pre-bundled node modules that are here, and we're using an alias. That's what this is. We can do aliases like this, where the alias is actually looking at, you can hover over, and it looks like this is representative of the lookup method that takes in a string, and it returns either string or false. Okay. So far, so good. And let's keep going. So we create the server like normal, and this time we're going to say let parsed URL is equal to this new URL. Okay. So instead of my path being what it is, I'm going to have a parsed URL, which the request URL and whatever the I kind of create a new URL. This is the API that I'm using, right? The new URL is going to include HTTP plus my host plus a colon plus the port. That's my parsed URL. All right, and requested URL is what I'm using here. Okay, that's my parsed URL. And then what I can say is my path, right, is I can replace my path with a piece of regular expression. So we can use this instead. Just modifying some of this. And let's just get rid of, we'll just comment this out for now. We can see how we can use this later. All right, so we'll comment all this out. So we'll say toggle block. Okay, so this is what path looks like now. And then if my path is equal to this, then equals to this, that is this part. All right, so that is this part that I was trying to do here. All right, so let's just put this back for a second, just get rid of path. So toggle block, get rid of this, just comment it out. Okay, so path is, we're parsing it this time, we're removing the slashes and so on. That's what this does. And it goes through and it detects if it is either this, as an example, then it becomes this. That's what this does. This parse file, it looks and replaces the path name with nothing. Okay, that's what it does. So it kind of cleans up our path name. It looks for those and replace them. That means that when I do this, right, I don't care about these cases anymore, right? If I get nothing, right, or if I get home or about or services or contact, so that's what this line does. It just cleans up the path, right? Then I can do index.html. That's what this does. So this is the only change so far that we've made. So path is index.html. And then what we're doing here is we're saying that let file is equal to this. So we're just breaking it out a little bit more. So we say that the file is something that we're getting there. So this is our file. And instead of using the path is actually going to be adding in the slash, right, for my read file. So slash whatever it is. Okay, so we take this away. We can just put in plus path. So dir_name plus path. And when we go here, we can just put in file instead of dir_name. So we're just breaking it down. And this is what allows us to do some troubleshooting. I can look at the file that we're looking at. So let's do a console log here to look at the complete file that we're looking to find, right, on the path, right? Cool. We have error content. We're writing our 404, right? And if there's an error, we write a 404, right? And we return. Otherwise, instead of using an else, we don't need an else. We can do this part. And what this part can do is replace this. We just have to remember that ours is data, not content. So we'll put data in there. We're just replacing the stuff that's in there. And then what we have is, and so why can I do this? Why can I do this instead of an else? Because return actually returns out of here, and it doesn't do this part, right? That's what return does. And it does a res end and return, and that's what this does. So this is, it'll stop operation of us here. It won't allow us to go further, so that's okay. We don't have to use an else statement in here. But now we have this set header and this idea of no sniff. So no sniff is a security feature because you can do something called Mime. So security it avoids something called Mime sniffing. That's what that is. That's what no sniff is. Because what you can do with Mime types is you can use Mime sniffing as a security attack. We'll leave that alone for another day. And then I do Mime is equal to, now this is interesting. I look at Mime again is equal to the lookup path. So here's lookup, and I have Mime. Let's change this to Mime types, just to make sure there's no clash. Mime types. Right? Again, I'm just modifying Mime types here. So lookup is Mime types lookup. Okay, Mime types lookup. So this Mime doesn't clash with that Mime. It wouldn't, because this is inside of another function, but why take a chance? Let's not do that. And let's put these if statements, these curly braces on top of each other, just to go with our style. All right, cool. So this is an error 404, page not found. And it's going to do this, no sniff. And it's going to say that let Mime look up the path. And whatever the path is, which is this path, home, whatever, about, services, and contact, it's going to try and find out the MIME type, right, of the path, whatever the path is, right, where path is a cleaned up path with shouldn't be any kind of slash. That's why it cleaned up the slashes in the first place, okay? So if that's the case, we can't pass in a slash in here, otherwise it won't know what it is, right? Won't know what the MIME type is. Then we should probably strip these slashes out as well and go back to that other way of creating the file name. So let's do that. So path is equal to this. It's the same path anyway so far, right? Because we're not changing the path. We're doing one step at a time here to make our own little routing. So we're going to put that in. So path plus a slash plus the path. That's the file name now. And path is cleaned up. So path can be put into our lookup. And then what we're going to say is, depending on the MIME type we get back, we're going to output a header that's okay with a content type that is depending on the MIME type that we look up. And then we're going to output with the data that we're getting. So read file, remember this read file? It doesn't trigger once. It happens for every file that is read, including CSS files, including other kinds of files. That's what it does. It looks at every single file and tries to read them all. So that's what it does. So doing this up here, which is interesting, right? Where it takes us to our index.html page over and over again. That's why we get multiple calls, because this is asynchronous and we're reading every file that we're doing from our little read. Okay, let's take a look at this and see what happens. So going back to this and going back, if I do a Nodemon and launch it, we start the server again. And if I go back to my server and let's go to this, we're good. We get slash. And let's take a look at what's happening on the server side, right? We can see what's happened. It says that, okay, I've loaded index.html. I went to my bootstrap min.css. I loaded my all min.css, a little app.css, router.js, all these things that loaded, right? And each one of these things happened when I went to file. That is the file that's loaded, right? That's interesting. So that's what it did. It loaded all those files. Okay. Awesome. Okay, that's excellent. And now what we want to do, file is this path, right? That's what we're getting. Okay, file is the path. And that's awesome. So now when we go to About Us, Projects, Services, and Contacts, we're good. But if I click Login, now we have a problem. And it says that's throttling thing again. Why is that? Because what's happening is somewhere in our code, it's getting us to read, as I'm hovering over, right, my little event is triggering over and over again from my app.ts. It's trying to read this push state. It's trying to read, to change this file over and over again. Okay, so even if I go back and try and change it and go here, right, this is okay, right? So far we're so good. But as soon as I go here and try and log in, I can get there, but not from contact. So that's a weird thing, okay? But what about logging in? If I go logging in, 1, 2, 3, 4, 5, 6, and click login, okay, that's neat. It logged me in. Okay, fine, everything's great. But if I click add, add's not working. Can't work, and I got nothing in here. Why? Well, what's happened for me is if I go to application, you can see that when I closed my browser the last time, it killed my local storage. So that's not a big deal. I can add in some keys and everything else later to produce this. This is not erroring out. This is just, there's nothing in local storage, right? How about in session storage? I do see my user and admin information. Nicholas says he's not getting any of those issues. So you're seeing everything fine. Perfect, right? Yeah. just be careful, Nicholas, because you may get those issues. But one thing that we're doing is, so services, about, projects, all these things are working. I can serve it up. But as soon as I come here, and if I try and enter some information, let's say, for example, I want to enter something, I can't even do anything. I can't do something at all, right? So notice when I'm trying to do something with my contact page, something is failing. And the thing that's failing is it's the way I did my JavaScript here is kind of coming out over and over again. Let me take a look at that and let's inspect that page again. You can see that I'm throttling the browser because I've got some kind of event that's triggering over and over again in my contact page. What is that event? It's pointing to that event. Router TS119 is doing this. That's not what it is. But this event here, which is my throttling event, and if I look at those things, you can see that it's all pointing to app.ts61, which is rewriting the push state over and over again. I'm loading my link over and over again somehow. I'm calling this function. And it's a bug that's inside my contact us page. Okay. But the rest of the pages, if I was able to leave this page, which I can't right now because I'm locked, if I leave this page and go here, the bug is gone. I'm okay. I can go to any other page, right? By the way, if I look at contact list, I can go there, no problem. But as soon as I go to contact, the bug returns. And you can see that that push state is where the error is. It's causing me to try and go back over and over again to my contact page. We have to look at that page to fix it. We're not going to do that here. Okay, this is just an example. So again, let's just go to fix it and go to log out. Log out works. Login works. Just my contact page is weird, right? Something's wrong with this page when I go to contact. We can inspect that later on. But one thing to note is that this is working, that we're able to serve static files, no problem, with this scenario, this thing here. Let's put this up on GitHub because this is an example, very simply, of what we did with our page. And all we're doing here is we're just rewriting the URL. It doesn't matter which page right now, it goes to these ones. And in fact, I can just simply remove all this and do what we have in here, because this does the same thing right now. If I just do this, right, then path is equal to this. That's the only problem. Otherwise, all paths are equal to this, aren't they? Right? Any path, the path that I'm getting, it doesn't matter what the path is. It's equal to this. And if it's not this or one of those other ones, then it's a 404, some kind of weird path, right? For example, if I go back to the page and I put in some other address, like ABC, and press enter, I'm going to get this error 404 page not found. And how is that triggering? Well, it's triggering from this. Okay, that's what's triggering the 404 page not found right here. I could instead, right, instead of reading this, my data, so that's the file and whatever, I could specifically look at the 404 HTML page. I could look here instead, right? And use that data. So I could, in my read file, if I get a page that I don't know, then I can change my my data so that it's a 404 page. Let's see if we can do that without breaking it again. So again, if it's case if it is something else, or default, if it's something else that I don't know what it is, then it is, we'll just call it a 404.html, like we did before. But this seemed to cause an error last time when we got a page we didn't know about, okay? So let's see what happens now. If I was to do that and go back and do this, we're good. But if I put a weird page in there, so sorry, if I put a weird page in there, like ABC, then it still takes us back to error 404 file not found, even though we put this. Why is that? Because what happens is when 404 HTML comes out, right, it's going to go here, slash, and it's going to say whatever my file is, my directory name, slash, what this is, 404 HTML. That's what this is, 404 HTML. And then it says there's an error. Did it find the error? because error says that somehow I didn't find something when I went to the file. That's what this means. Okay. So how is it then that my, what's my console say? So my console says that it's /abc. /abc. That is what I'm getting. Console log file is /abc. Well, why is that? Right? File is equal to directory name plus path. Well, because we need to put path is equal to this. Path is equal to this. Let's try it again. So if I go enter, now we get our custom 404 page. Okay. But if I put in other pages, like so, now it gives us our custom 404 page over and over again. Look at that, right? So why is that? Why are we getting our custom 404 page after the first time? Well, what about if I put in something like /home? Custom 404, we get nothing. It doesn't compute, right? And notice that down in here, we're not getting an update. It says 404, right? 404, 404, 404. We're not getting anything. What about if I put in /index.html? 404. We don't know what that is, right? There is no index.html. What about if I put in contact? 404. We're not getting something. Console log says refuse to go to this bootstrap. Here's the problem. Because the MIME type text HTML is not supported style sheet MIME type, and strict MIME type checking is enabled. That is what broke us. When we went to our 404 page, right, it didn't understand what to do. So again, I mean, you know what, it's so much work for us to get to this, but this is our first step into making our page, all right, into our you know, kind of our server. So for now, what we're going to do is we're going to save this and put it up on GitHub. So let's stop everything. So stop our page, and we'll say git init, git add dot, git commit -m. It's a lot of work, right? That's what I'm saying. Tons of work just to make sure our page links properly and all the stuff works properly, right? And there's going to be more work because Node is bare bones, guys. That's one thing. That's what the exercise is here. Node is bare bones. We'd have to kind of go through and do some kind of normalized path and a lot of work to do, right, for this. And there's no need for us to do all this work because it's already been done for us. There's always stuff out there that works that we can tap into, right? That works just great. Let's make a new page. So we're going to say ICE 8B. So WEBD6201 and winter 2021, and then ICE 8B. Make that public. And we'll grab these last 3 lines of code here, and we'll put them inside here. And why not? What? Add origin, git push. I'll be okay. There we go. And we should have everything. Yes. Awesome. Okay, so that is this. It says 7B though. That's not good. Let's refresh that to say 8. And this should say 8B. Commit changes. So that'll be your final. And I'll pull it. Git pull. So we have that update in the README file, right? And now what we'll do is up on line to end up the day for today, and we'll modify things later, right? Is we'll put in a ICE 8 final, which is what I'm going to put in here. So new URL, and we'll call this ICE 8 final, and we'll put in that link, which is this link right here. We have a lot of work to do to get to for the next day. So tomorrow we're going to do more work than this, right? Again, and the reason for this is because the we have to use something else in order for us to get our static pages working. Our static pages right now, the way it's working is we're working really, really hard to create server code to switch from one page to the other, to accept MIME types and all those kind of things. But just as a preview of what we're going to be doing next day, we're going to be looking at something called Express. So this is something we're going to look at, Express.js actually, not Express for men. Express.js is a web framework for Node.js. It's nice and small, right? And we're going to use this syntax. It has a great little API that we're going to tap into. So if we look at our guide for getting started, you're going to see that it does routing right out of the box that looks like this. So nice and easy. We're going to use an app.get for different kinds of routes. And that, my friends, is going to provide us with a mechanism for us to, to load files and so on and put things together. App.get and app.post. There's post and get methods. These are the things we're going to do next day. So look forward to this, because now we're finally going to be able to do our routing, as you can see here, just like this. All right, any questions around the stuff we've talked about in terms of Node, the way it functions? I wanted to give you a sense of how Node.js works, and that's why we went through this exercise. The exercise is, hey, look, I've got some built-in modules. There's some third-party modules. One that helps us with MIME types. Oh man, I got to do all this switching. That's a lot of work to do. And I've also got to specify port and host. That's okay, that's normal. But this create server is raw. I'm using raw API calls. And yes, I could look up the raw API and create my own server with Node.js. But holy cow, that would be a lot of work, right? And especially if I want to have multiple MIME types and I'm looking at JSON data that I'm loading, all this other stuff, right? I want it to operate locally, just like my light server does. My little light server is actually a little prepackaged bundled server that does static file loading, right? Really, at the end of the day, right? So I want it to do the same thing. And that's what I want my website to do. All right, any questions around what we did today? This is our first step into our in-class exercise. We're going to modify this afterwards when we install Express. All right, so that's it for today, guys. Thank you so much for joining. Tomorrow when we get together, I will show you how to use Express, and Express is going to give us a lot more capability. One thing we're also going to probably start trying to do is incorporate TypeScript. How do I use TypeScript with Node.js? Are there problems? You're going to see that there are. I think you're going to see a lot of little things, and this is going to help you understand how to make a back end combined with a front end. All right, guys, thank you so much, and I'll see you tomorrow.